Again, we are going to start looking at differentiation so that we can be able to start applying them in our mathematical connotations. Now, differentiation is defined as a relative measure of change of y variable with respect to change in x variable, and it is given by a symbol dy dx, or sometimes it is given by this particular symbol, or it can be given by this particular symbol y0 over x 1 x0. So it is more or less like a gradient. It is more or less like a gradient. Now, if we look at the symbol, it is given by the general formula, which is like f prime a. This is called a prime limit of h as it is tending to 0 of f bracket a plus h and minus f bracket a divided by h. So this is actually the symbol for this particular process. So if we want to now to get like the gradient, we can even have like an equation for this particular tangent, which can be associated with this curve. This particular tangent is given by this particular formula, which is equal to f prime a and the x minus a. So this is actually the equation that can be associated with the derivative. Now on the other point, we can actually say that if we have got a derivative of a function, for example, let's assume I want to find a derivative of a function a, which is equal to like f of x, which is equal to x to the power 3. So in this case, I can be able to use the formula which I gave earlier on, like this particular formula, okay, over h. So using this particular formula, I can be able to take f a plus h as equal to a plus h to the power 3. The reason why I'm putting to the power 3 is because the equation here has to the power 3. Therefore, if I simplify this, I can get a to the power 3 plus 3a squared h plus 3a h squared plus h to the power 3. So this is actually the value when this is applicable to that. And then if I want now to get f bracket a plus h minus fa, so this gives us this expression. I can actually take this particular expression and then subtract from it the value of fa. So in this case, fa is equal to a to the power 3. So that at the end of the day, if you can simplify further, you will see that this a to the power 3, this a to the power 3, it is cancelling with this particular part. So the solution for that, for the value is going to be given by 3 a squared h plus 3 ah squared plus h to the power 3. So this is actually the value that I have. So if I take now f a plus h minus f a divided by h, this implies that I will take this one, because this is the top part, h plus 3ah squared plus h to the power 3. Then I can divide this one by h. So you can actually see that from this statement, h can be taken out. So you can have 3x squared, and then I can have 3ah squared, 3ah, and then because I have taken out the h, and then I've got h at this point, and then divide by h. So this h and this h can cancel. So remember, the expression had a limit. So when h is tending to 0, so it means that when h is tending to 0, this particular expression which I have is going to degenerate to become 3a squared. So this particular 3a squared is actually the derivative of f prime a, which is now equal to, we can actually now come up with the statement to say the derivative of f prime a, which is equal to fx, which is equal to x squared, x to the power 3, is equal to 3x squared from the previous one. Therefore, we can actually now have a general equation to say given y is equal to like x to the power 3, then y prime is the same as dy dx is the same as 3x to the power 2. So what happens is, like now using the general formula, we can actually now say y if is equal to 3, if y is equal to x to the power 2, x to the power 3, then what is happening, that y prime then is equal to 3, you take the 3 multiplied by x, then you take 3 minus 1, which gives us a statement which is 3x to the power 2. So this is actually the value that we can be able to have. So I want us to have a practice on the same as to how we can be able to get a derivative of the following function. Find f prime x if and only if fx is equal to 4x to the power 2. I want us to find the derivative of this particular function. Find the derivative of that particular function. You can use the same equation and then determine how it can go. So having said that, let's look at another concept on the same. This one now is some statements that can give us a very good position. Now, if we have got processes, we have got some rules again associated with derivatives. So the first rule is called the sum or difference rule. So if you have got the f and the g as the function, we can actually have fx is equal to fx positive negative gx, and this implies that f prime x is equal to f prime x plus g prime x. So this can be giving us that particular statement. And in terms of number 2, we've got the multiplication rule. Now, under multiplication rule, we can actually say fx is equal to fx dot gx. And in this case, if I say f prime x, this gives us like fx prime gx, and I will now take gx prime and fx. So this is actually the sum. So it is called multiplication rule. And then we have got the quotient rule, which is number 3. The quotient rule, in this case, we can have a statement which could be fx divided by gx is equal to fx, like this, capital F. So if I want to get now capital F this, then I can be able to say this is equal to f prime x gx minus g prime x and then fx, okay, then over gx squared. So this is the way we can be able to solve it using the division rule. So we have got 3 rules that are quite important, which we must be able to take note of because it gives us some stance of the solving that we can have. A very good example which can be applied in this case to understand this statement is we can have the following. Let's assume I've got fx is equal to 3x minus 5, and then I've got 2x plus 8. Now for this one, I want to calculate the I want to determine the then I can get f prime for this is equal to bracket 3x minus 5 prime then 2x plus 8. Then I can take subtract, then I'll take 2x plus 8 prime and then 3x plus 8, and then thereafter I can be able to take this one 2x plus 8 squared. Then this is going to give me, now if I go inside this bracket, then I can only have 3, and then I can have this value, and then if I go in this second one, I can have negative 2 bracket, and I can have 3x plus 8 like that. So this one I can be able to take this as squared. So at the end of the day, I can now simplify to say what about f prime? Okay, what about f prime? F then is going to be equal to 6x plus 24 minus 6x minus 8. Then this over 2x plus 8 squared. So this gives us now common terms together. This and this can cancel, and this is 16. So we can have 16 over 2x plus 8 squared. So this is now the value of f prime x. So that's the way we can be able to look at. Now on the other point, we can be able now to consider like a mathematics or a sum which has some product. We can actually have a problem which has some product. Now this particular problem, it can be as follows. Let's assume we have got the f of x is equal to x to the power 3 and minus x, and at the same time 5x to the power 4 plus x to the power 2, like this. So f prime x, in this case it will be this one minus x prime, and then you multiply this, okay, and then you add, then you take the other one now plus x squared, and then you prime this, and then you take this to the power 3 minus x. So at the end, now you can start simplifying by going inside the equations. So when going inside the equations, you can actually say this prime is equal to 3x squared bracket 5x to the power 5 plus x to the power 2, and then it can be plus 10x plus 2x, and then this one you can multiply it with this other one, and then the rest you can be able to simplify and then determine what could be the value for that, and the like terms are being taken together, so that in the process you have got now like a fx prime is equal to 35 x squared minus 20 x to the power 4 minus 3x to the power 2. So I want you to prove this particular point. So I will continue in the next lesson on more examples so that you can be able to understand this. Thank you.